Welcome to China Manufacturing Decoded from Sofeast, the podcast where we take you through the major news and topics facing importers and manufacturers in China and Asia today.
Hello everybody and welcome again to another episode of China Manufacturing Decoded, our podcast that we hold every week. This is episode 88 if I'm not mistaken. Adrian is not here, so I'm never 100% sure, but I guess I get it right. And today, Andrew Amirnovin is with me. And for those who follow the podcast regularly, he's been on the show a few times. He is the head of new product development in our company, Sofeast. And he comes with a lot of experience. He's an electrical and electronic engineer and a reliability engineer, and he's been working mostly on reliability and quality through his years in a number of different tech companies. And we were looking actually with Adrian last time, and we said, hey, one of the episodes that was quite popular was episode 23, I think. Episode 23 on the NPI process. And in that episode, I simply went through, the 6 phases of our process for bringing a product from, let's say a concept, an idea, all the way through to mass production, right? And it doesn't mean we always work on these 6 phases, but it's nice to help our customers really think in a structured manner with some gates and making sure, okay, have you got all that right? Okay, then next step is this in a logical sequence. And that's really what that new product introduction process does for them. Okay, so and just to be very clear, we generally focus when it comes to developing new products. We tend to focus on electromechanical products, and we leave special situations such as medical products and other special situations where a lot of special requirements come into play. We leave them aside in this discussion. We'll just go for let's say consumer products that have some mechanical elements and that may have some electronic parts. Okay, so hi Andrew, how's everything going?
Hello Renaud, good to be here again. Doing fine. This is a great subject.
All right, yes it is. So this time, as I said, we're going back on the new product introduction process, and last time I really went through it and explained, but what people don't often don't get is why is it so important to do all of that work up front rather than trying to put together a prototype, hack a prototype together, it works, and then just go to a Chinese factory that does something similar, and then they will know how to bring it into mass production, right? Dangerous thought actually with a very new product, but people don't really know why. So I was thinking we take some of the elements of the NPI process that really most of the time should not be skipped, and then we explain why. Actually what happens if you skip it, what are the risks, right? So sometimes there's no severe consequence, and sometimes there are very severe consequences in skipping them. So it's all about risk management really in the end. So I was thinking maybe the first one we can pick is simply documenting the requirements. Okay, so you have a concept, you have an idea, this product is going to do XYZ, but okay, so put it together like a brief for your designer anyway. As you're going to work with an industrial designer, I would guess they will need to have some kind of brief to understand what it is. So what is the product supposed to be? But who's going to use it? In what environment? Why would they use it? What's their problem? And any performance requirements, anything special, that would be very important to really solve the problem that these users are trying to solve, right? And try to do it in a documented manner, and even try to explain step by step, number one, number two, number three, how it's supposed to work. Right, the user presses a button here, then they put this consumable, then what happens, and then until they have done the job, right? So putting this in a simple way in a document, maybe in a table or just free flow text is very important. But people will say, why? I can just explain quickly, that's fine, right? I don't need to put it all on paper. So Andrew, what would you say if they don't do that? What is likely to happen?
Oh boy, all kinds of negative and bad things can happen. Well,
Yeah.
I think this is pretty clear for a lot of experienced designers and engineers. They have learned what happens if they don't have some kind of a requirement document. In fact, in most companies, they call it product requirement document, or PRD, which basically entails in detail what the product looks like, what the features and requirements are, and how it's supposed to operate, what are the operation temperatures are, some of the reliability requirements, testing requirements. So they're very kind of like high level, but it's very clear what the product's supposed to be like. And if you don't have that simple document created, and then here it is, nobody really knows all the details of what the requirements or features or performance is supposed to be like, all you need to do is make a mistake and miss one of those requirements, and the product is not going to perform to specification. And God knows what kind of other things can go wrong. Trickle effect. For example, you didn't, in terms of design, you didn't, for example, have the right kind of a voltage. Now there's not enough power for some other module to work, or all kinds of, or you forgot certain requirement for reliability testing, and now as soon as it's dropped from half a meter, the product just basically breaking or shutting down or things. So this product requirement document in MPI phase early on is probably more like a plan. And if you don't have that kind of agreed with everyone, all kinds of hell can break loose later.
Yeah, right. Yeah, that absolutely. And when a quality engineer comes into play and says, okay, so later, like maybe it's 3 months later, okay, you put a prototype together, it's kind of functional, whatever. Okay, but you can't just give it to me like this and like I'm gonna give you my feedback. What is the checklist? Where are the requirements? At one point, it's going to be required anyway, and then someone is going to, maybe a quality engineer, is going to ask a lot of questions to make it more specific, right? Because it's extremely important. And I see actually people working sometimes with a manufacturer here, and things are never really documented. It must do that, and it must be tested that way, and things like that. And I'm like, but what? And then they say, but it has to be like the approved sample.
Right.
But that doesn't mean anything. Okay, if it's the wrong color, yeah, it's easy to spot. But what's the tolerance on this? Yeah, I don't know. I will check and I will tell them. Oh, really? But when there's 5,000 pieces on the shop floor already made, getting packed, and you see a problem, you're going to tell them it's not good. What kind of discussion are you going to get into? Right. So that's it's very, very fundamental, and it doesn't have to be very tricky or complicated. We even put together like a simple template that people can fill out with some examples, and it's not that painful, but it requires the person who has the concept in their mind to put it down on paper, because they have to understand their users. So it will force them to think what the target customers, target users, how they live their life and what they would do with the product and so on. Then, okay, this is about phase one specification, right? So let's go into phase two, what we call feasibility study or proof of concept. If a product is very simple, not very new, this is not very, going through this phase is not really important, can be skipped. However, if it's a very new product and they're trying to push the envelope on certain things, it does make sense to pause and do a study or a very rough kind of prototype, if you want, to confirm certain things, right? If we put it like this and it works like that, first, is it going to work?
Right.
I don't know, the pump and the motor and this, even in a very rough, in a very crude way.
You and I in the old days, we called it the kind of trying to validate the form, fit, and function.
Yeah, you could say that. Yes. But and it's not just validating about will it actually work, but also show it to some users and get them to confirm that, yeah, that's, it's kind of crude and so on, but it does the job, right? And so if you don't take the time to do that, and if you put some budget on that, and you have a team of people, maybe mechanical engineer and then software engineer and so on, and they do a lot of engineering design, and it takes months to get through, to some nice prototypes that are approved. What are the risks of basically skipping the proof of concept?
Huge. I mean, to put it simply, proof of concept is probably the most important part of the whole development early on, because as you mentioned, you need to have an idea of what the product looks like, how it's supposed to work, and whether or not you are on track in building the product. And if it's a brand new product that's never been in the market, which most of our clients are, they're entrepreneurs and they're creating a whole new product from scratch. A lot of times, they don't have the full experience of product development, and they don't realize how important that stage and that point in time is to keep all the documentations together, having the ideas together, making sure everyone has a clear understanding of what he has in mind as an entrepreneur, as designer. So yeah, I think that proof of concept is the key, very early on and very important.
Yeah, so basically if they skip that and they don't really take the time to validate it, and maybe to do a U-turn and go in a different direction that's more promising, and maybe doing proof of concept on 2 different or 3 competing kind of ideas, basically they could go head down way too fast into putting a lot of money in development for something that in the end might not be successful.
Absolutely.
Yeah. Okay. Another one is that even that early in the product development cycle, it's good to already pick the key components and key materials, right? And at the same time, to start to think of, okay, where are we going to buy that? Rather than, okay, let's just get something that's here on stock, and we'll bother about that later. And maybe, we're in the US, manufacturing will be done in China, because it's significantly cheaper, but for now, we're just going to pick some, we're going to go on Mouser or whatever other places where we can buy some off-the-shelf components like that. We're just going to hack things together. We're not going to think too much about where these components come from. And in some cases, that might be the right attitude, but in some other cases, that is rather dangerous. What do you think?
I totally agree. That is extremely dangerous if you really haven't thought through. I mean, just like you said, in some cases, if you're using a chip resistor, capacitor, or something standard off the shelf that everywhere is available, and you're designing that in locally for now until you go to China and you go mass production, and then you, try and source it in China. That might work. But then when it comes to critical to quality, critical to performance and operation products, like, for example, some of the ICs, key ICs and key displays and batteries, and some of the other key performance, like certain PCB types that you need. And then if you might say, well, I think we just for now use this IC or this transistor and so on for now until we get there. All of a sudden you get there, they don't have those parts because what you purchased is only local to US, or like you said, Mauser as a example, no offense to Mauser, but maybe that was very old part that is basically obsolete. And you didn't know about it. You're a young designer and adventurous, and here it is. Now you're in full production. You're trying to take it to full production in China, and they say, "Sir, we don't know where you got this part. This is no longer in the market." And it could also be a smaller chip resistor or something. But I mean, the risk of not being able to source a part that is not available or not available in higher volumes is huge. It could pretty much put a stop into your whole development and production. And so I think that it's very, very important that you think it through, find out, if how you're going to design everything at the end is going to work out in China. Maybe talk to a well-known manufacturer, like, for example, ours. We have professionals in purchasing team that know exactly what's available in the market here. They could just send an email and we'll be able to help them. And this kind of a connectivity to a manufacturer in offshore, in Southeast Asia like us, it's a huge benefit to a lot of entrepreneurs that are in Western, in US and Europe and other areas. They could just contact us and we'll be able to tell them, what the issues are with those parts, or they're okay. And a huge, huge benefit down the road for them in terms of risks.
And these days, already for more than a year.
Yes.
When you talk about electronic components, it's really important to pick one that is not hard to procure, because for some of them, prices have gone up 10 times, 20 times, or even more. And, there are very long lead times, or both at the same time. So if you're still in the early design phase, you got to work hard to pick one that is not that hard to procure, right? Because it's so unequally divided. I mean, some of these, these chips come from not just the chips and some other active components and so on, but some of these parts are made by foundries and manufacturers that are very, very, very busy, yes. And some others that are relatively equivalent are made by manufacturers that are not that or not much busier than usual. So take your pick, but don't make a mistake.
Absolutely. No. I think the timing for being very careful with risks related to components right now is very high, and they need to be really, really vigilant to contact someone like our company, so be able to make sure to lower the risk. Right now with the COVID situation, which they can't actually themselves be here across the country, travel to China, how are you going to actually contact Chinese companies and be able to talk to someone? Well, we have English speaking team members who can help them very clearly in what their objectives are and how we can help them. So I think that advantage.
Right. Another one is, so let's say they move along, they do some of the work, but they spend a lot of time and energy and resources polishing, a really nice prototype, and then they're like, yeah, this is really ready. If we get that in mass production, it's going to be great. But they never talk to someone who did a review for manufacturability, who did a review for quality, for reliability, and things like that. And we shot a few videos on that, right? Design for quality, design for reliability, and so on, for manufacturability, for assembly. Okay. What is the risk? Basically, they have a nice prototype, but they never get any feedback from, let's say, the manufacturing world. What can happen?
Oh gosh, if it's more like you're trying to build a product that you don't get any feedback from your end user. Long time ago, I used to work for an awesome company called Nokia. And the way we used to do was basically make 10, 20 different kind of models and then hope that one of them would hit the jackpot. Well, that's not the way it's done anymore nowadays. People do consumer surveys and they find out what the customers want. And then they design a product that meets their needs. That way you don't have to design 12 different products. You just design one real good one, and that's all that they need. They all love it. And I think that, for example, Apple does that a lot, right? They just got one iPhone every year, updated and so forth. And it works for them. I think that if they forget what the production requirements are, and they don't talk to someone in production and not have them review their bill of materials, their requirements for production. My God, I mean, here it is, ready for production, and all of a sudden production says, sorry, I can't start, don't have this particular part, don't have these jigs, don't have these, can't assemble these the way you have it, has to be in this format, you need to have this particular, for example, circuitry or assembly or jigs. So, I mean, it's very critical that before you go to production, have someone knowledgeable from that source, that production source, to really review in detail. And I mean in detail in terms of assembly requirements, testing requirements, and basically being able to put together the whole thing as a package.
Yeah, and so it's basically doing all the design work and then giving it to the manufacturing people to feedback like way
Right.
too late is called throwing it above the wall, right? Like you don't talk to them. You finish the package and then you send it over to them, and you hope that they don't send it back, because if they send it back, it means they can't do it, right? And then you have to make some changes, but you don't really know what to change, and then it's terrible. But these days, you're right, with COVID and all the travel restrictions, that's what some companies are doing because it's harder for them to come here. So, yeah, I guess the most common way that this takes shape is with the enclosure. Very often there's a plastic enclosure, a casing for the product with the custom shape, because that's the product identity, right? And then they 3D print it, and then they can do whatever they want. And it can be beautiful, it could be amazing. But then, okay, how are you going to make that in the thousands with plastic injection molding? Probably, right? In a cost-effective manner. Okay, well, this cannot be molded. Sorry, you got to change the shape. And you got to think of where the melting lines are going to be, and the flow lines, and when the gates and things like that. You need to think of all that in advance. So that very often requires some redesign. There's just one example, but there's so many ways it can, the design has to take into account the realities of manufacturing and of testing, and the requirements of quality, of reliability, and so on, right?
Yeah.
Okay, so let's say the design is made, the prototype is confirmed, it's been reviewed, by manufacturer and they say, okay, yes, with the changes you've made and everything, yeah, it's fine, right? Then comes the time pretty soon for testing, in-depth testing, right? Not like simple testing. So if some tooling is necessary, again, for let's say there's plastic casing, or I don't know, or extruded aluminum or something like that, and there has to be some tooling in place. Then okay, you make the tooling, you do an engineering build with that to get some final samples for approval, right? So it's important to take the time here before going into mass production. These final samples are extremely important. They need to be reviewed, they need to be tested, but maybe again by users, just to make sure everything's fine. And then how about certifications, compliance? Very often it's a must, but also for reliability. And we did a whole podcast episode on reliability before, but have you seen some companies just skip that and say, okay, we got the tooling, like let's go to mass production. I don't see any more samples to approve, and like I don't want to slow down.
Right. Well, you mentioned something really interesting about the plastic injection molding parts. These are like, for example, covers for some product that you're making. You need some plastic covers and so forth. Like you said, if it doesn't go through proper inspection by the engineering team who designed it, and they prematurely approve the part without actually looking at a number of samples, and then being able to understand what are the differences in texture, what are the differences in, for example, color, and so forth. If they don't do very detailed analysis, and especially tolerance analysis between parts, then you'll end up having all kinds of problems. And then, of course, as you mentioned about testing, full testing, and having a procedure that really catches all the issues during the production, so that the users don't experience having issues with the final products. A lot of times, let's say the designers, they have tunnel vision. They don't understand exactly how the product will be used. They've been assigned to a certain piece of the design and the project, and they pretty much just work on that design, and they don't even care what it is. Here it is, I have a PCB and I have to work on this module, and that's it. I'm doing my best, and that's it. The truth is, when you're testing it, you have to keep in mind what kind of environment this product is going to be used, how the user is going to be abusing it perhaps, or using it in a ways that the product was not necessarily designed for, and how much of it is important for us to keep in mind and take into account in terms of design, and how much of it is considered, for example, abuse, right? Take into, as an example, for example, the mobile phone. If it drops from 0.5 meter and all of a sudden your display cracks, I think it's pretty much unacceptable for $1,000 phone to break from 0.5 meter drop nowadays. Anyway, in the old days it was acceptable. I don't think it is now. However, if you drop it, if you throw it on the wall because you were angry at girlfriend or something, that is considered abuse. Then okay, we shouldn't design to to prevent that kind of abuse. But the point is, those are the kind of things that the designer must keep in mind when at the time of actually designing. Discussions needs to be around what are the limits of my design, how much I should design for it, and how much is not enough, and so forth. And then when you're talking about reliability testing, most often a lot of companies, they even don't even think about reliability, because it's not really something that is in their mind. And usually they run out of time and it's time to go to production. And here it is, they haven't done any kind of full reliability testing. So they start doing some rudimentary, very quick, what I call standard, kind of like standard off the shelf for components. They do standard reliability tests, which usually doesn't catch though all the issues that they could be having in the field. And they go to production. And then what happens next? Of course, because of lack of testing, they didn't catch a lot of issues, and they end up having a huge returns from the field.
Right. Okay. And then the last one, if we can cover this like quickly, is let's say you do all this testing on samples that have been put together by a few engineers with parts of tooling and like, in principle, all the same parts that would be used for mass production. Is this okay then to go into mass production straight and make, 500 pieces or 2,000 pieces? And our answer is always no. And that's one of these things where, we won't budge usually, except if really the product is obviously a low risk. It's no, we have to do a pre-production pilot run it depends on the kind of product, but often it's maybe 30 pieces, 50 pieces, just to double confirm that the assembly lines are ready, that the people have been trained, the components themselves don't come with a lot of issues and things like that. And it is a complement to the ongoing risk analysis for the product and the whole project. And it allows us to confirm that the issues that we have seen maybe before are not, let's say, their severity does not prevent us from going into mass production, right? And there's so many cases where people just say, okay, let's go into mass production, like I'm in a hurry, and they don't do the pilot run, and then they find out that 30% of their products are defective. Do you see a cause and effect relationship here?
Oh gosh, of course. I mean, production has its own issues and problems, but most often production knows what they're supposed to be doing when you have a small project going in. If the project has not been tested through the production, making sure that the production is set up exactly to meet their requirements, my gosh, you could be going high volume, like maybe make 1,000 to 10,000 units, and could be more than 50% no good in terms of yields. So I totally, wholeheartedly agree with you that every project, it doesn't matter if big or small, at least run a few samples through production and see if those are going to meet the requirements before you run a large sample. In many cases, you push the button and then 500 and 1,000 button. I mean, the products will come out at the end right away, very quickly in one day. And so, yes, it could be costly, very costly if you don't do the pilot run. And pilot run, by the way, has many different names, but it's the most basically an early production and production readiness is testing. You testing to see if the production line is set up exactly how to meet the requirements of this particular. For example, the assembly lines are ready. You got assembly operators are trained. You got assembly instructions and SOPs, and you basically there's a lot goes into making sure that the production is ready for your product, and you have to document all of this process. You have to check it, and you have to make sure that few, like you mentioned, 30 pieces that went through are actually meeting your requirements before you go to high volume.
And in many cases, especially for relatively complex products, or whether maybe some of the requirements are pretty tight, a number of different runs are needed, right? You do one, and then we have these and these and these issues, and like let's implement some countermeasures, and then let's go again into it, and let's see, okay, we still have that issue, okay, let's do another one just to confirm it's fine, and then okay, we can go into mass production without ramping up too fast, but we can keep that under control, right? So yeah, that's that's one thing I would never skip for an entirely new product that comes with a number of risks. Yeah. So that was just a few topics that we raised, that we focused on today. Obviously, there would be a number of others. Making sure you qualify the right suppliers and so on and so forth. But yeah, we would spend hours and hours and hours in that discussion, and maybe it's not that interesting. So we picked what we felt were some of the most important points, and where there's a very clear link from you skip it to you run very high risks, right? So we hope it was interesting. Thanks a lot, Andrew. Thanks for adding to the discussion here. That was great. And to the listeners, thank you, and you will hear from us as usual next week.
Thanks again for listening to this podcast, brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much, much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share, because it will really help others discover us too.